Alright, so today we'll be taking a look at some calculations from chemistry. Here we have Macmillan Chemistry, New School Chemistry, Bio. I recommend this ones a lot, CIC. This one is very helpful for those that wants to understand calculations. That's our chemistry past question by my boss, Mr. Odeshino himself. Then we have laboratory manual in chemistry, practical chemistry, and this is one of the textbooks I strongly recommend for students, Essential Chemistry. Now, today's class is a very easy one. I want to continue from where I stopped in my previous video. We spoke about calculations on water of crystallization. And from calculations on water of crystallization, I said that 8.1 gram of XSO4.7H2O. Now, this is the expression I was talking about. Here, where you have this expression here, XH2O over molar mass of anhydrous salt is equals to mass of water lost over mass of anhydrous salt. This is the expression we guys need to know under water of crystallization. This expression, if you are good to go with this expression, you can solve literally all questions on water of crystallization. Now, if you look at number 1 here, they say calculate the amount of water of crystallization in the intermediate and final salt. Intermediate, English in chemistry, that is the first, initial, and the final. The initial, that is the temperature here, 90 degrees Celsius. That is what I calculated. You get your XH2, which is 18x. Just try and solve it. I get now more of you, less of me. I've solved these questions countless number of times. I'm trying to position myself properly so our students can catch a proper view of the question. I don't think any of the questions should be a threat. Number 2, we have your XH2O over molar mass of anhydrous salt. That 4.10 gram is the mass of the anhydrous salt. To get the mass of water loss, you minus the first from the final. I get now the mass of water loss, that will be 4.10 minus 2.00. I think that should give us 2.10, I guess so, yes. So that will be mass of water loss 2.10 over mass of anhydrous salt 4.10. Then here you have a 18x over molar mass of anhydrous salt. Always get the anhydrous salt. This is the anhydrous salt here, MgSO4.SH2. This dot here means you add a particular mole of water was added to this salt. So for this place you add. Why for this x here you times? H2O is 18. We always know that one by now. Oxygen is 16. 2 times 1 2 for hydrogen. So that is 16 plus 2, 18. So we always get 18 for x. That's why most time when you see me solving, in my solving for XH2, I used to put 18x. I always use 18x to save yourself the stress. Number 3 says on eating 5 gram of hydrated copper tetraoxosulphate 6 to constant mass, 3.20 gram anhydrous copper tetraoxosulphate 6 were obtained. If the formula of the hydrate is CuSO4.XH2O, calculate the value of x. This is the same thing too. Just remember this formula often. You can read this 7 times until it sticks to your brain. XH2O over molar mass of anhydrous salt is equals to mass of water lost over mass of anhydrous salt. So here we have 18x over molar mass of the anhydrous salt. For number 3, I think they even gave you already. The anhydrous salt is, okay, they didn't write the formula, but you should know. Copper tetraoxosulphate 6, that is CuSO4. Hydrated, yes, water was added to CuSO4. Copper is Cu2 plus. Tetraoxosulphate 6 is SO4 2 minus. This is a radical, a group of atoms carrying charge acting as a single unit. Always interchange. There is a particular textbook that I did not showcase, outline chemistry. Outline that one, I used to call it a very small bachelor. It has a lot of calculations there. They explain this one, interchange the positive value of the valency. So this 2 goes there. Okay, 2 cancels 2 actually, basically. So you're just left with CuSO4 for copper tetraoxosulphate 6. This is what we call cupric sulfate, or we call it vitriol. This is vitriol. It is blue in color. I think I explained it in my previous video. It is blue in color. Now, number 4 and number 1 are similar. Here they say 7.60 gram of, you can pause the video and write out the questions for solving. 7.60 gram of blue, I've told you it's blue in color. Number 5, okay, let me explain that number 5 so I'll not procrastinate or postpone what I'm supposed to do. 7.60 gram of blue copper, okay, story. Calculate the stages of degradation which are at 100 degrees Celsius and 120 degrees Celsius. For number 4, you write it out at 100 degrees Celsius using this expression, XH2O, that will be 18x over molar mass of the anhydrous salt. That is, remember the anhydrous salt here is CuSO4.SH2. So you do 63.5 plus 32 plus 04, that is 4 times 16, which is 64 plus 18x. Add everything up. I think that should give you 249. I doubt, I'm just trying to remember what I did back then. 249 plus 18x is equals to the mass of water lost at 100 degrees Celsius. This was the actual mass, 7.60. Minus, then later on it gave us Okay, first heated to a temperature of, the residue that was obtained at 100 degrees Celsius weighed 5.40. So this was the mass. So that would be 7.60 minus 5.40 over the mass gone. That is 7.60. So with mathematics, you can stop. Like I used to tell one of my students back then, chemistry stop, mathematics takes over. Make your S the subject of the formula. For this place, you do 249.5 times this. You get your answer. Then you minus this first. This will give us 2.20, I guess so. So you times this with this. You also times it with this. You are going to have x. Then collect like terms and you get your x. I think it should be 2 and 4 respectively. When they say respectively, I think in English, it's not that